Hi, this video is the solutions to the Core 1 end of module test. Question 1. We have to differentiate this. Now, I can get it ready for calculus. This is technically ready for calculus. Remember, a fractional power means rooting. 3 times a half is 3 over 2. And now I'm ready to, put a 1 there, now it's ready for calculus. dy dx equals this times this. This reduced by 1. This times this. This reduced by 1, that's 1.5. Reduce it by 1, you get a half. Tidy that up. Oh, sorry, if that's dy dx, I should name that y, just to make it clear where y is coming from. Tidying that up is anything to the power of 0 is 1. And you could tidy it up to be that. But just copying that down there is perfectly fine. Now, here I got that ready for calculus. It's probably worth your while to learn a shortcut, which is that whenever you face anything like this, so a constant term and just a constant timesing by x, the derivative is just the constant multiplying by the x. This disappears and the x disappears. That's just a shortcut rather than going through this whole rigmarole of developing a zero power. So that's question number 1. Question number 2 is integration, the reverse. This also requires you to get stuff ready for calculus. Note that I've left out the unnecessary brackets. This is me getting it super ready for calculus. And now you have to come up with the expression which, if you differentiated it, would give you that. Now I recommend when you're starting out, use this template. Compare each term to this. So for example here, k is playing the role of 1. So 1 is playing the role of k. Compare it to this template. 1 is playing the role of k. 3 is playing the role of n. Over here, 1 is playing the role of k. Negative 3 is playing the role of n. Once you've satisfied yourself what that is, replace it with this. So for me, that's 1 over 3 plus 1 x 3 plus 1 plus 1 over negative 3 plus 1 x 3 plus 1, and then you have to add the plus c to express the fact that there could be any constant on the end which disappears when you differentiate it. Now it's just tidying. And there you are, that's the answer to that one. That's question number 2. Question number 3. Okay, sigma notation means you have to do substitutions. You have to substitute in this first, this last, and every whole number in between. This is me substituting 3 for r. This is me substituting 6 for r. But I said every number in between as well. So 4 and 5. Now sigma means not just do that, but stick plus signs in between. So that is correct. That is the meaning of this. But they usually want you to simplify it. So that's 4 plus 3 plus 2.4 plus 2. So that's 11.4. Now, by the way, that's not an arithmetic sequence, so you can't use any of the arithmetic machinery on it. So you can't use any formulas like this or like this, all that jazz. You just add it up. It's 4 numbers, doesn't take that long. Question number 4. Okay, negative powers are easy. You just temporarily ignore the negative power. Okay, so in my head I've got this. Now, powering a fraction, just do it in 2 stages. Power the top, power the bottom. So, you get 1 over 9. 1 squared is 1, 3 squared is 9. But the negative power simply means you have to turn that answer upside down. So there's the answer. The answer is 9. In other words, that upside down. If it's a whole number and I say turn it upside down, Like if it's 5, just imagine it's over 1 and turn that upside down. As I said, negative powers are easy. Temporarily ignore the power. Do your thing. I've written it over here just to be safe. When you're satisfied with your answer, present it upside down. So that's Roman numeral part 1. Here's Roman numeral part 2. Okay, so fractional powers are like a backwards question. You have to look at the denominator of the fraction and think, it's now my job to invent a question where the answer is 16. Now it needs to be a multiplication question, and it needs to involve the same number repeatedly, that many times. Now you muck around, the answers are usually 1, 2, 3, 4, 5, 6 or 10. Not always, but often. And my mucking around tells me that 2 times 2 times 2 is 16. So when I look at that, my job is to invent that question and store in my head the number 2. Now I look at this and I power that answer up by whatever power that is. So the answer to that is 8. Now the technical term for what I've just discussed is that fractional powers are a code for rooting. Rooting is the technical term for this process of coming up with a powering question which gives the answer that you physically see. So the answer to 16 to the power of 3/4 is 8. First I got the 2 and then I cubed it up to get the 8.